investment in transport. Nevertheless, the development of biofuel, however, may lead to the creation of new and great opportunities for industry and companies. But oil crops like soy, canola, and palm require arable land, water, and even petrochemical-based fertilizer, putting an enormous stress on our biosphere, making it and sustainable means to produce biofuel for the future. In Italy, as in the many countries, in the other countries, the problem is further complicated by the lack of land available for crops expensive and by the reduced availability of water supply for agriculture. In working with nature's natural system, we can maximize a means of economically producing the algal oil for a clean and burning, domestically produced alternative to petroleum. Making fuel out of algae is one of those ideas that everyone loves. An acre of algae can produce 50 times more oil than 1 acre of soy. So, research into algae oil as a source for biodiesel is not new. The current oil crisis and the fast depleting fossil oil reserves have made it more imperative for organizations and countries to invest more time and efforts into research and suitable renewable feedstocks such as algae. Dell'Unesco, my company, has been testing growing algae both in open pond and in bioreactors. A major conclusion from this analysis is that both systems may be advantageously used in different conditions. The open pond raceway system are the least expensive. We believe that anybody use the growth elements or make being as the basic capability to manage an oil open pond raceway system. The main problem of pond is contamination that can be reduced but not completely avoided with inexpensive and easy to use plastic greenhouses. The bioreactor is a complex self-contained, computer-managed system that needs very small maintenance and that can give very high yield in even smaller area, but it greatly improves the output with artificial lighting that increase the cost of operation. Japan has set up a system optical fiber-based system that would dramatically reduce the amount of surface area required for production. Algal biomass contains 3 main components: carbohydrate, protein, natural oil. The economic of fuel production from algae demands that we utilize all the biomass as efficient as possible. We plan to use the natural oil for biodiesel and the remaining mass for animal feed. But we are also considering the possibility in the future to use also biological gasification on the non-oil component. It's important to remember that the current agriculture is an essential component of the fish aquaculture. To conclude, dell'Unesco is going to put on the market system self-contained made of diesel electric power generation that will use the biodiesel produced in either open pond or bioreactor system by the middle of 2009. The small quantity of land required, the fully automated system, the use of all the alga mats, the possibility to use of any kind of weather are characteristics that make the alga culture interesting of Italy, but at the same time may become a serious and viable technology meant to produce oil to make energy in many countries in all parts of the world. Thank you very much.
Thank you for the time. I remember that Wabt has promoted one of the chair of UNESCO in Sultanate of Oman on marine biotechnologies. One of these partners from Souci, the professor of aquafarming technology in Göteborg, and there they work also on algae, but for toxicological algae and other things. And Professor Hua from India yesterday proposed to us to work with the National Agency of Fishery and Aquafarming in India to develop a new program for this aspect of, special aspect of aquafarming linked to the Mediterranean area too. The other professor from Messina, a friend of Francesco, so we discussed yesterday the same thing. This is a new exciting area on biofuel and remote energy with biotechnology. I don't know if there are other people from the Italian platform who want to do very short intervention, as Professor Sicurello, President